this. So I have my top yellow in the oil, bottom yellow in water. Yeah, we don't have shutting, we have only this. So what we do next, calibrate. So we need to have more trick because we have a different threshold in water and in oil.
Okay.
Yeah. So go to the bottom. It's 0.999, 997. If I pick all points, yeah, more or less okay. So I just take the threshold, zone 2, copy.
But my line is only positive.
Okay, because you hide your emphasis.
Oh, okay.
Okay, so you hide it. Yeah, when you hide, it's the so. So go to bottom and just take the intercept of zone 1, sorry, zone 2, copy into the threshold. So both arrows are showing, pointing 0. Is that okay? So go to zone 2, you have the intercept. So I have my intercept positive for 10, intercept negative -7. Yeah. You should be having more or less similar. Okay. So the top one, yeah, you have this green one. I just unpick, but it's not big change here, yeah, because the RPS goes to 0, and sometimes it's not reliable because plus minus threshold. So I'm not using it. So the slope might be a bit changing. Then I just copy threshold as the total intercept divided by 2 for the oil. Yeah, because we don't have it from shutting. If we do have oil threshold from shut-in, we might use that. But since we don't, just put total intercept divided. And then transition will be deep already. So I just click OK. Cut off. Yeah, maybe just leave it here. NA. Yeah, something like that. You see at the top is more or less good in tubing and the bottom, but in between here, yeah, I think you might have some different slope. Yeah, people down and up, they are not consistent. The up pass is not consistent like the down pass. So yeah, if you want to see only the down pass, then you might be seeing something like more consistent. Yeah, you can do this one. For example, you like to calculate only the down pass. Just put 0, 0, 0, 0, 0. Then I click OK. Then you see this is more consistent. Yeah. I need to put some threshold. Sorry, to cut off. I think it's 0.5 should be fine. I am maximize the flow and I right click show spinner cutoff line. If I click edit, I let you put maybe 0.5. Yeah, we can use 0.5. And click edit and click show. Then I recalculate VF using 0.5 or 0.46. Yes, not a big change. 0.2. doesn't really change. Yeah. So you can, when you click apply, you can see if you want to change in this cutoff. Anyway, so I just use 0.5, and I have something like this. Then what should I do now? PVT. So PVT I need to copy. So click open, and I go to additional file. There is EPP. Yeah, you have it. You go to open, and you go to additional files. Additional file, anything with .epp. Yeah, so Emerald PPT. So click on that one, open. So I have PPT according to the file. You can see there is a standing and you have BO, you have some constraint here. Yeah, you have some constraint already. So there are some table constraint. You can see also if you click the first square here, if you click, you might see all the data, all the dots, all the red squares. Click cancel and click OK. So I have my PPT. Yeah, with the constraint. So then we need to put some QCalc. So click on QCalc. I like to update plot layout and interactive zone definition. Then I click OK. So where should I put QCalc? The top one here. Yeah. And then you have click another one. Click QCalc. Maybe here. Yeah, I need to adjust the blue one in front of the SSDs. This is the one SSD. So adjust that one. And then we do that one. It's difficult. That's it. So we just do that one, and then the second one, and the third one, you can put somewhere here. So you see the contribution from maybe from this top one.
So the top inflow zone you like to
SSD.
like sama depth dengan SSD or bigger
No, some.
sama depth.
Yeah. Should be some other. That one. Yeah, this is a bit difficult.
Yeah, because later it will affect the
Yeah, masih ada effect IDM, yeah.
the queue-nya.
Yeah.
Okay.
So maybe I just put that one in the IDM part. Or yeah, we can put that one. Cinema. We can put that one, and we have everything here, examples, yeah. And then we put the bottom one just close to the yellow zones. Yeah. So I just put the coding perforations. It's at the top one. I can adjust this one maybe a little bit on this side. So I have the bottom one. I have all in casing. There's an idea. I can see where it start to move. Yeah, it's probably here. Okay. And after VF, we go to rates. So because we do have PVD of water, oil, gas, so we'll go directly to 3 phase. Yeah, we can do that one, and then I click OK, and OK again, and something like this.
3 phase what?
Hmm?
3 phase.
Yeah, 3 phase, just default. You okay, Jaya?
I'm trying to follow. I'm trying to follow. I'll start with the
Sure.
spinner first.
Yeah, just go to info. You make DBDC. Just make DBDC.
Okay, wait.
And then you calibrate your capacitance and set the tool ID of tool OG 1.7 per silent. You understand?
Mana orang di sini minum kotak?
Tapi mereka tak gemuk minum manis.
Sini tak ada orang gemuk.
Iya, ada orang gemuk. Mesti saya susah cari baju di sini. 4XL
Oh,
yang jual sampai tertawa. It's the only one 4XL.
beli dua pak. Jahit. Susah. Mainan emosi tu.
After DPDF, DPDG.
Yes. And then you go make a new interpretation.
Okay.
Okay, just make the, what do you call it? Oh, sorry, go to tool first.
Okay.
You make the calibration of the capacitance and flow meter and plate diameter 1.7. 1.7. Go to a cup and then right click, show edit capacitance, what do you call it? Calibration lines. And you do that one. Okay, so we see you have some negative here, yeah? Because it's negative. It is correct or not? When it is really negative, if it is moving down, I would expect that the water level will be dropped. Yeah. If the bottom part here, the bottom zones are T-fins, so I would rather say the water level will be dropped about up to here, or maybe below, because it's cannot taking just oil or whatever. If it takes, then the drop levels, yeah. This just indication if the level stays there, so it is indicate this is an 8 here, not a real dot plot. You've done the capacitance, yeah?
Go to capacitance, right click.
Show edit, show tool calibration, and then edit.
Tak keluar.
Kena klik dari
Capacitance,
kiri.
F, klik kanan, show capacitance. Show capacitance calibration line, you show it, you can?
Okay.
Yeah, and then you edit. And then you take the red and blue line from 0 from left, move it to the right according to the data. So water and oil. Okay, so we have something like this. So this one is not really correct. Just wait, Jaya.
Capacitance, cap, edit.
Show, okay, kena show dulu.
Show first and edit,
You
and then
besarkan
drag
kapasitan.
it
Okay.
from left. Dari kiri.
Okay. Dari left. Betul-betul dekat left. Dia sebab dia dekat kosong. Dia
Because the first
dia
number is 0, so it's
dia dekat
all
zero
on the
number.
left side.
Yang dekat zero tu you drag, nanti dia keluar. Oh yes. Ada sekejap. Right click. Cuba right click. Edit show. Tengok show. Okay. Edit. Okay, edit. Okay. Yang ni oil, kalau blue water.
Macam ni lah.
One more.
You have it? Yeah.
Tadi
you
air
have
pun
the same?
jadi tak keluar.
Yeah.
Ya, dia
Kenapa dia main suruh-menyuruh?
The green light is
saya rasa kalau nak senang kan,
So you
Dekat
adjust
tool
that
tu,
one. You can zoom in
you
first.
klik dekat
You
tool.
zoom.
calibration,
Zoom.
number 0 ke apa ke kena tukar macam 1 ke apa kan, nanti dia keluar kan.
You
Sebab dia dekat
adjust
0.
this one. And you need to adjust this one first.
Okay.
now.
Dah macam ni, and then dah tak payah
Yeah. And then that one.
cancel yang dia punya show
Yeah,
tu.
more
Oh, okay.
Yeah.
Right click and then
And then
show,
this one.
tak
Yeah.
payah edit, and then
And the
tak
bottom
payah show.
More. Yeah. So
And then boleh buat
just,
spinner
just do
zone.
this one again.
Macam ni lah.
Faham?
oh
Yeah.
spray on the
Yeah. So you put the home button again to go back to the screen.
But ADF only happen in deviated well or vertical well also? Can happen?
Kemarin kita ada 3 condition,
Uh-huh.
3 condition.
Uh,
Deviated,
deviated.
low rate, 2
Okay,
phase.
okay. Alright.
Deviation can be just 10 or 5 even. Ya saya pernah lihat itu yang cuma 5 derajat, PADF, karena low range. Ya bisa. Bukan low rate tapi low velocity. Karena
Okay.
bisa casing besar, big casing, tapi velocity is slow karena
Big,
ID-nya besar. Ya.
Berat.
Yeah. Usually it happen in the big casing.
Okay.
Yeah. And small casing is still usually it's very rare.
Belum pernah lagi dalam tubing kan?
Nah,
Bukan spinner.
Spinner buat 2 zone ya, satu dalam tubing, satu bawah. Okay, and then calibrate. Copy je threshold. Ikut zone.
So my first slope is negative.
Mode 3.
Oh, mode 3. Anyway, just I feel negative. Copy dia tak copy.
Negatif. Okay, sama. Negatif. Bawah. Tengok bawah. Zone bawah. Yang threshold tu. Copy. Copy zone tu.
So yang ni tak perlu lah.
Cuba tengok sekejap ni.
Sebab kalau dia negatif, kita tak perlu copy.
Itulah.
Kita copy.
Oh, okay. Tekan threshold. Yang tu set value. Yes. Okay.
Okay.
Alright.
Okay. Ini dia tukar.
I ambil down pass je. Yang up pass 0.
Kosong.
Okay. Tu PVT, ada file PVT yang you load je. Open dekat atas folder. Bukan sebelah ni. Okay. Ada PVT file. Additional. Okay je. And then Q card ikut dia.
The size 3.8. The Q card size.
apanya?
The size.
I okay je.
Okay je.
Ambil yang tu, yang
Interaktif.
interaktif.
Oh, okay. Interactive ya.
Okay.
So habis dia antara yang agreement
Kalau kita pilih top of perforated interval ni, and then kita adjust, sama juga.
boleh sama
Sama, okay.
sama
Cuma dia automatic
ya,
keluar.
lebih cepat,
Oh, lebih cepat.
tak perlu satu-satu.
Di atas make sure yang inflow warna biru tu ngam-ngam dekat SSD.
Ya, the top
And then
one is essentially
bawah tu ikut zone lah.
Why
Besar zone warna hijau.
we had the cube over the back?
where you mean this one?
No, above the back has
Yeah.
gray line.
Yang ni tu
Why
okay.
we have
Yang ni
to
tu okay.
above the
Dah
pattern?
look tadi
Okay.
Okay, you tell me.
And then nothing happen lah, PVT je. Okay,
What's
ini nothing
the
happen lah.
Okay.
Lepas tu Q cup. Lepas tu, okay. Buat zone yang warna kelabu.
Above the buckle, right?
Yes.
Why it had the gray?
Oh, you mean the block?
Kita
You
kasi
mean
tahu
the
dia.
block?
Okay.
Ya okay je.
That one? On the
Buat
block.
zone.
The block is the
Okay.
surface, right? Convert to the
Buat
bottom.
satu lagi,
So
nanti
you can
biru
see on
tengah-tengah
the
keluar.
info, you have this number.
Okay, biru tu
This is
buat
the number.
you letak schematic, senang.
So if I right click here, if I'm not showing surface rate, if I untick, now, yes, yes. So that
Biru
you
tu
can
buat dia ngam-ngam kat tu.
So the surface rate converted to pressure temperature at this top calculation because
So
surface
biru,
has
biru,
different
biru.
PD.
Biru atas ngam-ngam kat SSD,
So when we
biru
convert,
bawah
you need to
ikut
have
hijau, biru bawah sekali pun ikut hijau juga.
BO.
Okay.
Volume factor.
Yang warna grey I pun tak
So
tahu
you
dia pilih macam
compare,
mana.
convert to the bottom hole PD. So this one is comparable with the same pressure temperature. Okay, we need to do, there is an option, we have it in Emerald, ADF. So what we do now, click on rates. So you click on rates, go to the second, which is there. So you see the measure is minus 33, yeah. But then I don't have my ADF, so I need to have water hydrocarbon L.
Water hydrocarbon L.
Yeah.
Okay.
Because oil is bubbling up in water. Yeah, we cannot do in three phase. We need to choose whether water oil or water gas. Cannot be oil gas. Yeah, I think that's this the limitation. So if you click on that one, yeah, a bit positive now. Then if I click this one, I will update the schematic. Something like that. It's magic. So if you want to use the ADF, you can use like this. So you might estimate the rate at the bottom, even though the spinner is negative. So,
Carbon.
yeah, remember yesterday, if it is liquid, then we'll be using ABB deviated correlation to get the VS. And the hold up is, yeah, you can have the hold up here from both capacitance and also DVDC. So you make those two hold ups and average both of you and then calculate the slippage from ABB. And you have the C or the constant, you can see this one, C is 1. And then this is the offset. So if you go to edit, there is CADF and PADF. So this is basically a gain factor and offset. It's a number that you might be changing. Velocity is velocity of light phase is velocity slippage times 1 minus you guys hold up. And this one, we have you take CADF, yeah, CADF times this one, which is the light base, and plus CADF.
What is actually C? Constant or?
Yeah, it's constant.
Okay.
So we don't know. It's just as a factor. That's why we choose one. But it can be less than one. Can be more than one. That's the gain factor, right? This is the gain factor. And this is the offset.
Yes.
PS is depending ABB or liquid. ABB for liquid, WL for liquid fast. Yeah, times PS times yeah,
It is what?
gain
Huh?
gain factor.
Gain
This
factor.
gain factor. So you can have if you need to be bigger, you can just put gain bigger. The thing is, it's difficult here because we don't know what gain and offset we need. We need to really use it.
Normally, when we choose the ADF and then it's gone, or
We need to, if, okay, there is another thing we need to consider. If the water level, okay, let me draw. Yeah, water level. Yeah, water. So you have some coming up, and your spinner, okay, for example, this is 0, yeah. And your spinner is giving you, oh, this is already VF. So you have some, start no negative, right? Negative, and then you have some water. And then you have some positive, and then you have another positive. Yeah. So this is your idea from here. This is the one. And this is the one there. Then you have above this one is single phase. Single phase, right? For example, oil. This is only oil. And this is only oil, right? So you can calculate the oil, the amount of oil from here, depending on this number.
okay,
And then you calculate the ADF here in order to have positive. So in order to have something like that one and straight line here. So whatever the IDF calculated is the same with the single phase. So you adjust the C and D ADF according to that one. Because we know above the water level is just oil, but the oil has to come from here, right?
we just take
Take that one. Yeah. You can do.
Okay.
You can do just take that one, a calculation zone, that's okay.
Oh, okay.
So you have a positive.
Mm.
But if you have calculation here or there, and you adjust according to the velocity there.
Mm.
That's good if the water level is not in from the above.
Mm.
But we have here, the water level is in front of the bird. Or that one here. In front of the bird, so we don't know. And above this one, it's not because of only from the bottom, but it may be from that perforation. So if the level is not in front of the bird, it's good.
Okay.
But if it is not, then yeah, you live with this number.
Confusing.
Okay, so that's the idea. Yeah. So it's number one is using idea. I can just this idea. So let's try to the second one using the temperature. Yeah, let's try to use the temperature. So we make a new interpretation and, for example, temperature. So we'll copy the PPT. We don't need to copy the spinner. We don't need, we copy the calculation zone, that's okay. Apparent velocity, we don't. Yeah, we don't. Input channels, yes, okay. So we put that one.
What is actually input channels?
Reference channels.
Reference channel. Oh,
The-
okay,
yeah,
okay.
the
The one that we
temperature,
select.
yes.
Okay.
ID, temperature, pressure,
Okay.
capacitance, DPDC.
Mm.
Okay. So I will go to the second one, classical with thermal. When you choose this, you will go automatically to continuous. Then what we go next, spinner, of course we don't do, just untick. And we go reference channel. This one we've done one. The airflow I don't need. Delete. Then I need to go to temperature.
Yang most buat ni. Our colleagues once show us about this,
Okay.
but we don't understand.
So we choose protection, yeah?
Protection.
So then we need to calculate the heat loss coefficient. So yeah, in this version, just click tab dependent, click OK, click this one. So you can have a different completion from the top from things, but we are in two conditions. So I just put one. I just put make it simple. Just make it simple. Just make it simple. So I have this tubing. Just click annulus. So tubing ID 2.99. Tubing OT 3.5. Casing ID. I don't know what's the size of the casing. I think it's 7 inch, right? Just make it 6.18. And casing OT 7 inch. Cement OT 8.5. And then tubing heat you can see this one here from that one, the heat capacity or this one this one is thermal conductivity, not capacity. Capacity is this. So we use this one, thermal conductivity. So for example, is carbon steel 36 to 54, just make maybe 40. Yeah, tubing is 40. Annulus is filled up by oil. So oil, yeah, maybe 0.5. 0.5. Casing the same, 40. Cement is 1.3, so it's 21. Then I try to compute. Yeah. So this is my heat loss coefficient from the reservoir to the sensor in the center of the tube. Radiation, deconvection, yeah, we don't do that. Okay. And then we like to have the TGU. This is the important one. I think I just leave it like this first. We can adjust later on. Just click and OK. Yeah. Then I need to adjust the TGO. So click OK, and then you go to TGO. So this one, I need to maximize it. And I like to make TGO should be at the bottom here. So what should I do? I click pick nearest. choose this DMP, and then I click this DGO, that one, and I choose the place. So probably very low at the bottom, something like this.
Sorry, Pak, again, Pak. Temp, when we choose the
Okay.
temp.
So pick nearest,
Okay.
go to DMP,
Okay.
and then in the browser,
Mm-hmm.
you'll be having DMP.
Okay.
Uh, this is that one, and you have this one,
Oh, okay.
DGO. So we'll follow the, I mean, we'll set the slope to get as a DGO. Yeah. So you click on that one and then you choose the interval as the DGO. So I just put that one, click, drag, and release. Just the most bottom gradient. Yeah. So something like that.
Mm.
Then I will adjust the inflow source. Yeah. So for example, this is, okay, let me just zoom in. So you see the starting moving up from the geothermal is probably this one. So I just adjust this blue according to that one here, starting deviate from the green. Yeah, and then yeah, it could be here. That one is starting from this one here.
Okay.
And the top one is only up to here. So you can divide by 2 for examples. But then that's okay. So then the top one, I might use just the whole operation. I need to move this back. Yeah, probably somewhere here. Can see that I'm starting into yeah. So you just try to see the changes here. So the changes from here to here. So I just put that one around here, and that one is created from this tab. So it's moving up here. So I changed the tab according to the temperature change. You might adjust it. Yeah, you adjust this one and that one. And after that, you can just go to inflow. Then I could man surface condition, click add surface condition, and just go for it. I need to change the water to 0. I change the water to 0. So I just click water 0, I lock it, and I do global input again.
Something much.
No, it's not really good, man. I don't know, I need to put the delta before. Set reset, and I lock water. Maybe I need to change this one. See, quick pause. of wood. Yeah, something like this. You can see the temperature is not very good, but you might try to, I don't know, but gradient. So if you go to inflow, you can go to temperature and you look at your gradient. Is it 0.020? This is I mean, sorry, not gradient, the geothermal. More or less, it's fine. If I change point forwards, it should not be when changed. The water is always there. Yeah, something like this. So again, the geothermal gradient is really affecting. So if you change a bit, it might be very different. So yeah, you get that one here. Hmm?
Temperature of the wind.
Oh, you need to get
Only
the
dia
geothermal
buat
gradient.
rates
You need
based
to
on
get the
temperature ke
geothermal
bukan speed.
gradient. Geothermal gradient, the TGO. So TGO, your TGO is away on the right side. So go to temperature match. So click nearest curve, maximize that one, click nearest curve, choose this red one. No, the bottom one, go lower. Click that one to that one.
Yes.
Yeah, going
I
down.
dah tahu dah mau buat macam mana.
Going down. Yeah. Only to click again.
Selama ni dia tunjuk tak faham.
Move down. Click and drag. Click, hold. Click, hold. Drag down. Down, not up. Going down. Yes. So I choose this one. I click on that. And I use this one. I choose the bottom part. And yeah, you should be moving in. Let's try again. Click on this one.
Ini velocity match.
Click and drag.